Welcome back to the video, guys. In this video, we'll be looking at question 4, 5, 6, and 7 of activity 2.4. So first, let's start with question number 4. Question number 4 says that we are given a system of linear equation and we have to select the set of correct options. The first option says the system of linear equation has a solution. Okay, so let's do one thing. Let's try to analyze this system. Okay, so we are going to express this in the form of Ax equal to b. So if we write it in the form of Ax equal to b, it is this matrix 0, 1, 0, 0. Then we have 0, 0, 0, 0. Then we have 1, 1, 0, 0. And then in the next step, we can write it as 0, 0, 1, 1. No, instead of just writing the coefficient matrix, I'm going to write the augmented matrix here, which is represented by this. So I'll write B here only. So 1, 1, 1, 1. Okay. So here I can see if I check the row number 2. So in the row number 2, here I have all the zeros in the matrix A, but the corresponding element of the known vector B is not 0. What this represents? This represents the equation 0x1 plus 0x2 plus 0x3 plus 0x4 equal to 1. And we know there exists no such values of x1, x2, x3 and x4 which can satisfy this equation. Thus, the system has no solution and the system is inconsistent. So the first option is correct. The first option is incorrect, whereas the second option is correct, which says the system has no solution. Now moving on to the option number 3, which says the determinant of A equal to 0, where A is the coefficient matrix. So yes, the determinant of A equal to 0. Why? Because R2 is a 0 row. R2 is a 0 row. And we know that if there exists any 0 row in your matrix, then the determinant of your square matrix is 0. Okay, so this was all about question number 4. Moving on to the question number 5, it is asking us about the dependent and the independent variable. So let's write the augmented matrix first. So here we have 0, 1, 0, 0, and then 1, 1 over here. And here we have 0, 0, 1, 0, 1, 0. So to identify the dependent and independent variable, first we express our matrix in the RREF form. So this matrix is already in RREF form. Once we have the matrix in the RREF form, we identify the pivot columns. What are the pivot columns? We mark the pivots, that is the leading entries, and then the columns corresponding to those pivots are your pivot columns. So column 2 is your pivot column and column 3 is your pivot column. Now the variables corresponding to these columns are your dependent variables. So x1 corresponds to the column 1, x2 corresponds to the column 2, x3 corresponds to the column 3 and x4 corresponds to the column 4. So if the variables corresponding to pivot columns, writing here variables corresponding to first the pivot columns are your dependent variables. And then the variables corresponding to non-pivot columns are your independent variables. Thus, x2 and x3 are dependent, whereas x1 and x4 are independent. So x2, x4 is an independent variable is the correct option here, and x2 is a dependent variable is a correct option here. Now moving on to the question number 6, it says suppose a system of linear equation consists of only one equation and 4 variables. Find the number of independent variables. So again, let's write the coefficient matrix here. which is 1, 1, 1, 1. So here, this is my first pivot entry and the only pivot entry. So this is my pivot column, and the variable corresponding to this pivot column, which is my x1, is the dependent variable. So I can write x1 as the dependent variable, whereas the variables x2, x3, and x4 are independent variables. Independent variables. So there are three independent variables. Another way to look at it, I can write x1 as a minus x2 minus x3 minus x4. So here the value of x1 is dependent on the value of a, x2, x3, and x4. I can anytime change the value of x2, x3, and x4. Hence, these three variables are independent. And depending on the values of these variables, the value of my x1 will change. Hence, x1 is dependent. Now, moving on to the next question, where we have AB as the augmented matrix of the system of linear equation. And it says this denotes the reduced row echelon form of the augmented matrix corresponding to the system. Which of the following options are correct? The first option says the values of A and B cannot be determined from the given information. So first let's write the augmented matrix here, which is 2, 1, 1, 3, 3, 4. Now we'll be doing the operation such that this matrix becomes the identity matrix, which is provided over here. Okay, the first operation that we can do is half of R1. So half of R1 will give us 1, 1 by 2, 3 by 2, and the R2 will remain unchanged. So 1, 3, and then 4. Okay. The next operation we can do here is R2 minus R1. R2 minus of R1. So that would give us 1, 1 by 2, and then 0, and 3 minus 1 by 2, which is 5 by 2. And here we have 3 by 2. 4 minus 3 by 2 is 5 by 2 again. Okay. The next operation that we are going to do here is 2 by 5 times of R2. So what it will do, it will make it 1, 1 by 2, 3 by 2, and this will become 0, 1, 1. And then we are left with just one more operation, that is R1 minus half of R2. R1 minus half of R2. That would give us 1, 0, 3 by 2 minus 1 by 2 is 2 by 2, which is 1. It is 1, 0, 1. So A and B are 1. A equal to 1 and B equal to 1. So the first option that says A and B cannot be determined is incorrect. A equal to B, but their exact values cannot be determined is wrong. A equal to B equal to 1 is correct. This is incorrect. The solutions for x1 and x2 are not unique. So here, see, we started with the augmented system AV, right? And we performed some n number of elementary row operation, and we obtained a different system which is RC. So if we start with an augmented system and if we perform the elementary row operations, then the solution of the system Rx equal to C is equal to that of Ax equal to B. That means if the system that we had here, which is the system 2, 1, 1, 3, and then 3, 4 here, is equivalent to the system 1, 0, 0, 1, and then 1, 1 over here. So if we write the equations corresponding to this system, which is 1 times of x1 plus 0 times of x2 equal to 1, and then 0 times of x1 plus 1 times of x2 equal to 1, that will give us x1 equal to 1 and x2 equal to 1. So thus the system has unique solution. The system has a unique solution. You can also have this thing in your mind that if uh, the RREF, that is the reduced row echelon form of the of the coefficient matrix A is an identity matrix, then the system has a unique solution. When the system Ax equal to B has a unique solution. Okay, so let's check the option. This says are not unique. No, it is incorrect. It says the system has a unique solution, so it is correct. So it says x1 equal to x2 is a solution. However, it is not possible to determine whether the system of equations has a unique solution or not from the given information. So this is also incorrect. So thus we have completed the question number 7 as well. So this was all for this video. We'll see you in the next video. Till then, bye.